Assalamualaikum, salam sejahtera, we meet again. Today we're going to go into chapter of equilibrium. You have learned before that a force, whenever if you apply a force to a body, this is the body lying on the floor. The moment we put force at any point, the force can cause the block. Two kind of motion. Either the block can slide to the right, or the force also, because there is a distance from the ground to the point of force, the force can also cause the block to tilt, spinning. This is what we call the moment effect. And slide we call the translational effect. The block slide or the block spin. So how to know whether the block will slide or not, depending on the friction between the surface of the block and the floor. How to know whether the block will tilt or spin or not, also depending how strong the block is glued to the ground. But that's not the issue here. The point that we're going to learn today is anytime a body is applied force onto it, then there is a reaction. Either the block will slide or the block will tilt. Then come to the concept of equilibrium. When we learn static, everything is not moving. No motion. So by saying that, so whenever we put the force, what are the things that make the block won't slide, won't tilt? Then it comes to the concept of Newton's third law, saying that whenever there is a force applied to any body, then there is a reaction, of which the magnitude of the force is equal magnitude of the reaction. The direction of the force is opposite direction of the force. The force going to the right, the reaction going to the left. That is the Newton third law says. Whenever there is a force, there is a reaction that against the motion of the block. The block won't slide and the block won't tilt. In this situation, imagine that the block is grounded to the ground. So then this particular region is giving the reaction, of which whenever you put a force, as if I'm clamping the block here. So whatever force you put to the ground, clamping it won't slide and it won't tilt. So the opposite direction of the force that's stopping the force from sliding the block is the reaction force, and the moment on the floor is the reaction moment that overcome the effect moment by this force. You know, whenever you have a distance between the floor, ground to the point of force, let's say we call it D. So the moment by force at point, let's say this point A, at A is equal to D times F. So this is moment acting, Can you call it moment acting? And equal to the moment of reaction. I mean, the moment effect by the force that try to tilt the block here is countered by the moment at the floor. You say that now even try to turn it, I will not let you turn it. It's a moment reaction at the floor here. So for solving the equilibrium condition of the static here, then we come up to the 3 equation or 4 equation or 6 can be. But it grows from the 2 basic equations, saying that the summation of force of this rigid body is always 0 and summation of moment is always 0. From here you can develop them in the summation of force x is equal to 0, summation of force y is equal to 0, summation of force z is equal to 0 if it's 3D. Same thing with the moment, summation of moment x is equal to 0, summation of moment y is equal to 0, summation of moment z is equal to 0. So we are using these 3 equilibrium equation. Equilibrium means everything is 0 to solve the static problem. Okay, before we going further into the 3D of the equilibrium and also before we're going into the rigid body equilibrium, let's go back a bit to the particle equilibrium. Imagine in this situation if you are hanging a mass of unknown weight on a 2 pulley. Of course, the pulley is hang on the floor or on the ceiling with a pin. So imagine if there are 2 mass on both sides, each having the weight of 10 Newton, and they are hang at the angle of 30 degrees. So then asking what is the weight of the mass here to make sure the system is in equilibrium. And when the thing is statically staying like this forever, we call it equilibrium. Or static equilibrium. So for doing this, we have 2 equations. Summation of force x is equal to 0. Summation of force y is equal to 0. Again, whenever you do the engineering analysis, always name your axis. This is the y, this is the x. So then you note in your equation, force x is positive to the right, y is positive to the upward. So in this situation is the x, the y is here, so you know the mass here is a downward, sorry. So downward is a negative mg minus, you see minus? No? And then if you need to draw the FBD here, so the FBD of this particular series point A, FBD at A, you have that this is the mg and this is the 10 Newton, because the pulley having a frictionless, whatever the mass, the weight on the weight here, they're all the same weight along the cable of the pulley. So this is going to be 10 Newton with the angle of 30 degrees, and the same thing here, having the tension of 10 Newton with the angle of 30 degrees. So this is the complete FBD that you must draw whenever you do the assignment, the quiz, the test, and the exam. Normally I'm giving about 20% mark for the correct FBD. That means FBD you must clearly saying that where the FBD about at the point A, show all the forces involved in the FBD, label them, whatever angle given, use put it back there, whatever value given, put it back there. If you throw it correctly, you get 20% of the mark normally. Okay. From this FBD, the equation at the FBD at A, and you're getting that mg plus 10 sine 30 plus 10 sine 30 is equal to 0. From here you get the mg is equal to 5 plus 5, 5 plus 5, and then you get the m is equal to 10 over g. And then if you need to find the summation of force x is equal to 0, of course you don't have to solve it, but just for the sake of completing the calculation, then you know this is the F positive, 10 cos 30 positive minus 10 30 cos is equal to 0. Then confirm that 10 minus 10 it is 0. Then you prove that your equilibrium is achieved from this formula.